All right, hello people watching this video. We are in review time. It's been a long chapter 6 review. All log stuff. What we're gonna do is just like normal. We'll do one together from each section. Would you like me then to give you time to finish the other ones? Yeah, sure. Okay, so if you're watching this video and want to skip through when I give them time to work on the other ones from those sections, you can skip along in the video. So this might be a little longer of a video, but just know that you can skip, okay? So 1, 2, 3 come from section 6.1. You can't really see it because it's like behind my hole punch. But 6.1, I have these blocked off so you can tell what sections each one of these are from if you need to use your notes. 1, 2, and 3, let's do one of them together. Which one would you like to do? 3? Okay, now before we do that, look at these functions. And these are exponential functions. Are they growths? Are they decays? What are they?
2 are decay.
2 are decay and 1 is growth? You're wrong.
2 of them are growth.
They're all growth.
They're all growth. The only number that you look at is the number that is to the x power. We don't care about this 3. So this one is doubling each time. This one is going to the, tripling each time. We don't care about the 1/3. This one is taking times 5 or quadrupling? No, that's 4. Quad is 4. Quintupling each time, whatever that is, right? So we're going to do number 3, and we're going to do a couple positives, couple negatives. So we'll do, I just always do -2, -1, 0, 1, and 2. And see how that comes out. Might not come out very nice. Might be some that are off the graph, but that's okay. And then I usually start with 0. So if we plug 0 in, what's 5 to the 0 power? 1. 1 times 0.25 is? 0.25. Woo, 0.25. Okay, now I'm going to go first power. So 5 to the first power is 5 times 0.25. What's 5 times 0.25? 1.25. Okay, now let's do 2. 5 to the second power is 25. What's 25 times 0.25? 6.25. Is that right? Maybe. 25 times 25 is 625, so I just moved the decimal. It's probably 625. Okay, now let's do -1 power. Blech. Yucky. -1 power. 5 to the -1 power is 1/5, right? Negative powers, just flip him. So 25, 0.25 is 1/4, right? 1/4 times 1/5 is 1/20th. So that is -1, 1/20th, whatever that is. It's a really small number. 0.05, 0.05. 0.05. Right? Okay, now -2 power is going to be 1/25th times 1/4. That's 1/100th, or 0.01. So we're just getting smaller and smaller and smaller. All right.
Why are we plugging them into the x number?
Because that's where the x is. We're just plugging them in for x, and x just so happens to be the exponent. That makes sense? So -2 is at 0.01, so really small. -1, not much bigger. 0 is at 0.25, so we're only still at 1/4. 1 is at 1.25, and then we're at 6.25. So there, that gives us a nice good graph. Is this a growth function? Like we said? Yeah, it's growing, right? And then here is my horizontal asymptote. You don't have to write them in there, but I always just kind of like to put that dotted line in there. And then the last thing that we want is domain and range. Are we doing okay so far?
Domain is all real.
Domain is left and right. He will go left and right forever, so he is all reals, like Caitlin said. Yep. Range is up and down. Will he go up forever?
No.
Yes. Will he go down forever?
No.
No. We're only talking about y's that are
Greater than 0.
greater than 0, like above 0. Is it equal to 0?
No.
No, because it's not going to touch 0, right? That horizontal asymptote is there.
Keep getting
Okay.
closer.
All right. Do you want time to do 1 and 2?
Use the review on our test.
No. You're going to be fine.
No.
You're going to be fine.
No, this is like Miss
What?
Amateur. This is like legitimately one. I'm not.
You're going to be fine. You're going to be fine.
This is legitimately one. I'm not gonna be fine.
3 times 1/3 is 1. Like 3 times 1/3. 3 times 1/3. What is 3 as a fraction? 3 over 1, right? 3 times 1 is 3. 1 times 3 is 3. So 3 over 3 is 1. It's a third of 3. Think about like the number 3. If you section 3 off into thirds, how long is each one of them? 1.
So 9 times 1/3 would be 2.
No, 9 times 1/3 is 3.
This is geometry.
9 times 1/3? A third of 9. This would be like 9 times 1/3, 9 over 3, which is 3. Yeah?
This is geometry.
Okay. What?
Are we supposed to do 1 and 2 by ourselves?
Yes, go ahead and do 1 and 2 by yourself. I'll give you some time, and then we'll move on to the next section.
Can you come look at this and see?
Sure, sure. Okay. So, if you're watching this video, if you're still watching, you can skip through this until we go to the next section.
Sorry, I'm trying to figure out what is this right? Like, did I do this right? Because you would do.
That's exactly right.
Okay, I didn't know if I like.
plot those. Yep.
Yeah, I didn't know because that 12 goes right off.
Right, I know. Some of them might be like if you do from -2 to 2,
So this is-
some of them might be off the chart. That's fine.
That's from -2, -1, -2.
Yeah,
And that's be 1 thing. So what would you give with x be 1?
So you're plugging in 1, right? 3 to the first power is 3.
3
A third of 3
is 1.
is 1. So it's 1. Okay. Then you can plug some of these into your calculator.
Yeah, and
Right? So
2.
3 squared is 9.
Yeah.
9, a third of 9
It's 2.
is 3. Right? So you have those points.
These ones are low.
Yeah, those ones might be a little high. So 3 to the negative first power. No, 3 to the negative 1 power. Negative powers make him a fraction. So 3 to the negative 1 power is 1/3. It just flips it. Goes down.
Was it?
Yes, still positive. Positive 1/3. So 1/3 times 1/3 is 1/9.
9.
Right? Okay. Now we have 3 to the negative 2 power. Okay, what's 3 to the positive 2 power? 9. So negative 2 power would be 1/9. Right? 1/3 times whatever 9 is 1/7. Which is really small. All those points in here.
I have a question.
Okay.
Is it?
Yeah.
Is that
Mhm.
okay? Because I was like, I'm not sure. Because I got.
These should all be small numbers because you know it's going to grow, right? So it's gonna be small numbers
Yeah.
and then develop
So
into big
it's
numbers.
that.
Yep.
Okay.
Yep. Okay.
How would you count that 127?
What? 127 is just going to be right above the thing. Are you? You're not well done, Romeo.
I am done.
No, you are.
What?
Okay.
I am done with 1 and 2.
Okay, then you go down to 6-2 and you can start doing
I don't
6-2.
know how
You
to
start
do
to the
that.
next ones. Yes, you can.
They're pretty easy.
Yes, you can. Try to do them. What do you do?
No, I don't.
What's your strategy there? You can figure it out. You can figure it out.
First 2, they're not good.
Yeah, they end up being fractions. It's fine.
How about number 5 is good.
I don't know how to do
Yeah,
this.
we're gonna do number 5 together. Are we ready for the next section?
Wait, no, hold on. I'm writing down.
Okay,
data
all
ready
right,
for the
okay.
last one.
Okay, we'll wait for you.
So
Okay, I'm good.
number 1, I put -2 in for the x, and I got 3/4.
Yes.
I put -1 in, and I got 3/2.
Yep.
3/4 is bigger than 3/2, so.
No. 3 over 2 is 1.5. 3 divided by 2 is 1.5. 3/4 is underneath of 1. 1.5 is above 1. I think you're thinking
Oh,
two.
I
You're
saw
thinking.
the one.
You're thinking 2/3, Josie, not 3 over 2.
Okay.
Yeah. Okay, let's do 5 together in the next section, and then I'll let you go for this one. No, 5 is harder. 5 is harder than 4.
Yeah, 5.
Okay.
You do 5 in head though.
Now my deal is 8 and 1/16. I want to try to get those to be the same number. Okay. Now later on in the chapter, we start to do things that you can't get to be the same number. So if I am not able to get 8 and 1/16 to be the same number, what do? Do you remember?
Close.
No. No. If you cannot to get them to be the same base, what is your strategy? But what happens if it's like 5 and 3? Like you can't get them to be the same base. What did we do in the last section with the story problems? No. No.
You change
No.
1/16
No,
and
you don't. No, you don't. You're wrong. Because you can't do 8 to 4. What do you do when you can't get them to be the same number?
I don't know.
You log both sides,
You have to.
Ew.
right? You put a log in front of both sides. No. Like if you can't get them to be the same number, you log both sides, right? Okay. All right. So this one you can get them to be the same number, but Romeo's wrong. We can't make them 4 because like 4 squared is not 8, so that doesn't work. So what do you have to do?
1/16 and a 4.
That won't work because then the 8 won't work. What?
Put in the -4.
So we have to make them 2s, right? We have to make the base of 2. So 2 to the what power gives me 8?
3.
That becomes 2 to the 3rd power. And then I've got x minus 2 equals, now 2 to the 4th power gives me 16. But what's 1/16? Negative 4th power, right? Fractions are negative exponents. And now I just get rid of my 2's. Okay? But this 3 needs to be distributed. So this becomes 3x minus 6 equals negative 4. And then we add the 6. 3x equals 2 and divide by 3. X is 2/3. You betcha. Okay? All right, so do that same thing. Try to get them to be the same base. In this section, you should be able to get all of them to be the same base. It's later on in the chapter we can't get them to be the same base, so we log both sides.
Can I use the restroom real quick?
25
You have to right now.
Kind of, actually.
Can you wait like 10 minutes?
I'll do square root of 125.
Ah.
Okay. Okay. Okay, keep going with this.
Wait.
I need help.
Like, especially number 7 is terribly easy.
Wait. I have a question.
How do we do that one?
Okay. Now, 25 squared is not 125, but can you break both sides out?
5. Why did they give you such little room to work with?
Yeah, literally, it's like,
Okay. My brain just, well, okay. So do I
Not
just
writing big.
distribute those?
And
Okay.
don't have it,
Yep.
So it'd be,
mine fits, I don't know what your problem is.
2 plus 2.
well, yeah, mine fit, but I just had to write smaller, but it's fine.
I'm right, mine plus.
Now solve.
okay.
Michael.
I was just making sure.
Okay.
Nice.
How we doing, Isaac?
Lost.
Okay. Alright, which one are you solving? Okay, this one. 4 and 8. I want to try to make them the same
What
height.
did you give us?
So I'm going to change them to choose. So 4 is the same as 2 squared. Okay? So I'll rewrite him. And this is x plus 1. This stays the same. So we just took the 4 and moved it 2 squared.
Should be 4.
This would be, hold on, equals 8. 2 to the
No, 3.
third. 2 to the third. And then we have 2x plus 3. Right? Now we cross off the 2's. Now we distribute this.
2x plus 3.
2x plus multiply.
Oh, 2.
2 equals
6x. Oh, no.
the curves is 9. Okay, now let's get the x's together. Which one would you like to move?
6x. No, 2x.
Let's subtract the 2x over. So 2 equals 4x plus 9. Okay, now let's move this 9 over.
So,
Minus 9 now equals 2 minus 9. Negative 7. Okay, then divided by 4. Negative 7 divided by 4.
You can continue.
Okay, let's go to the next section. Next section, I don't know if we even need to do this one, but listen up so we can do these next 6 really fast. We're going to do these 2 together, okay? This is a log function. Each one of these are logs, and we're trying to make them exponential functions, okay? So, these are just the switcheroos. If I make him an exponential function, what's his base?
15.
To the
Second power.
equals
225.
225. Okay, let's go down to the one below it. We want to make this one into a log, so he has to have a log with base of
7.
2 equals, or no, of, excuse me,
128.
128 equals
7.
7. All right, do those 6, or the other 4. Those should be really quick and easy, and then we'll go to the next one.
I need help. That one and that one.
We're going to do that one together. And, yeah, we're going to do that one together.
But what do I do?
Back.
28, right?
That's 25 to the 1/2 power. It means, the 1/2 power means the square root, right? Yeah.
Number 20. Do you take the 6 and
I'm done.
No, you're not.
Oh,
Are you done with the
I
bottom
know
part?
how
Take
these
it
ones
to
are.
that power.
Oh, wait, I'm done.
You take it to that power.
Okay.
Wait, really? That's it? Oh, okay.
No, like, we only have to do the front
We're
side.
going to the front side.
And I'm doing.
All right, are you ready for the next section?
No.
Biceps
Hang
days,
on.
I'm gonna deadlift. with
18 is tricky. Did you do 18?
18.
If you moved on, did you do 18?
No.
No?
I did all of them, yeah.
I didn't know.
18.
What'd you get?
Okay.
All right, let's look at 18. We want to solve this thing. So how do we do this?
You change it to an exponential function.
So we say equals x, right?
Yeah.
This is 100 to the x power equals 100,000, right? Okay. 100, if I square it, that'll have 4 zeros.
Ew.
No, 100 if I square it has 4 zeros. 100 if I cube it has 6 zeros. This one has 5. So how the heck do I do this? Well, maybe it's right in between. I don't know. We'll see.
Right in between.
Let's switch both of these to 10s.
Right.
100 is the same thing as 10 squared, right? What's 100,000 the same thing as 10 to the fifth power? Now I cross off the tens, and I have
2.5.
2x equals 5,
Uh,
and divide by 2.
5/2.
X is 2.5, or 5/2. I don't care how you read it. Tricky, tricky. All right, do the other ones. Those ones are quick and easy. 16 and 17 should be not too bad.
They're not bad.
No, not bad. Okay. All right. And I'll give you like 30 seconds, and then we'll move on to the last 4, and then we'll call it a weekend, right?
I just feels like I broke my arm.
How do I do this?
I don't know what happened.
Yep. And then switch it around, Josie.
Mention too hard.
No, it's the forearm. It's the forearm muscle right here, dude.
I got
Okay.
29.
Wow.
Oh, yeah, you got 28.
On which one?
Thank you. Number 22.
I don't know.
Right here, Michael.
What do I?
Yeah. You should have gotten like,
Thank you, Riley.
Like-
72.
it doesn't come out nicely.
Riley.
Negative 20 over
Thank
8.
you for saying that out loud.
Whatever that is.
If you hadn't told me the answer, I would have put the wrong thing.
28 over 8. The 4 is positive though.
Wait.
It's
I-
4 minus
hey,
24.
Can I have some help?
So it should be just negative
So
20.
how do I?
Geometry?
Right?
Use a check it.
Here, look. This is how you do it.
Doesn't even help.
Look, this is how you do it.
But it's positive 4. 4 minus 24.
Romeo,
What is she?
you better have me pinned on messages.
What's the 4 with this?
On messages. On messages. Better pin me on messages. I pinned you on my messages.
It's not in the parentheses.
I have a question. Wait,
You
wait,
better
wait,
pin
wait,
me.
wait, wait, wait,
I think I'd be pinned.
Bro, look how bright it is.
Oh wait, no I don't.
Okay.
Romeo, Romeo, I forgot which one I was in.
All right, let's go 21 and then we'll be
Which
done.
one's you?
21 is the one in this section, and this is maybe a little bit harder, okay? Isaac Mack, you need to watch this. Here's your equal sign, okay? I want to be able to shoom some logs off, but I can't because these have 2 of them. And plus means multiply, but before I can do that, half to the back. Okay, if you do the 1/2 power, what's 25 to, what does that mean? What does the 1/2 power mean?
Divide by 2.
No, nope. It means the square root of 25, right? So what's the square root of 25? Will you answer that? Thank you. It's 5, right? Okay, now plus means
Multiply.
multiply. So this is log base 6 of
5x.
5x equals log base 6 of 20. Now you can cross them out. So 5x equals 20 and divide by 5. X equals 4. So multiply means, or add means multiply, minus means divide. You want to combine things and then cross some logs off and be done, okay?
Can I use the restroom real quick?
Now you can, yes. I'm going to stop this video. That's all we're going to do today. On Monday, we will finish the back side of this. On Tuesday, we will do some whiteboards. On Wednesday, you will have a test over this chapter. Holy cow. Goodbye, people in the video.